This is 2009 FRQ number 4 in the non-calculator portion. All right. So let R be the region in the first quadrant enclosed by the graph of y equals 2x and y equals x squared as shown in the figure above. Find the area of R. Well, we know y equals 2x is linear, so this is y equals 2x. And then y equals x squared is our parabola, so y equals x squared. Find the area of R. This one is easier to do dx, so we go top minus bottom. Okay. So for part A, R is equal to the integral between 0 to 2, top function 2x minus x squared dx. And our derivative, you have 2x squared over 2 minus x cubed over 3, evaluated 0 to 2. Simplify that to x squared minus x cubed over 3, 0 to 2. Plug in the 2, you get 2 squared is 4 minus 8 over 3. Plug in 0, you get 0. So, like so. So you can do crisscross applesauce, or you can know that 4 times 3 is 12. 12 minus 8 is 4. So my final answer is 4/3. Okay, that's it for part A. Part B, the region R is the base of a solid. For the solid, at each x, the cross-section perpendicular to the x-axis has this area of sine A equals sine of pi over 2x. Find the volume of the solid. So this is actually kind of nice because you don't really need to figure out how to use the region, because I already gave you the area. All you have to remember is that this one still integrates from 0 to 2. So the volume of this particular piece is still 0 to 2, and they already gave you the area function that you need. All right, so this is very straightforward. Integral of sine of pi over 2x. The antiderivative of sine is negative cosine. So negative cosine of pi over 2x. Keep in mind that chain rule, pi over 2 here, you need to take it out but reciprocal it. So it's 2 over pi. And now you divide it 0 to 2. Okay, so you get negative 2 over pi cosine of pi over 2 times 2, so cosine of pi, minus negative 2 over pi cosine of 0. Okay, so what's cosine of pi? Cosine of pi is negative 1. Negative 1 times that is 2 over pi. Minus minus, so plus 2 over pi. Cosine of 0 is 1. So 2 over pi plus 2 over pi is 4 over pi. That's your final answer for that volume piece. All right. If it says it's the cross-section is going to be a different shape, that's where you have to come up with your own area function. But they already gave us an area function. So all we had to do is put this into here and know that it's going to build on top of this, but still build from 0 to 2. 0 to 2 here. That's how we're able to just make the integral and go. Okay? All right. Another solid has the same base region, same base R. For this solid, the cross-section perpendicular to the y-axis are squares. So write, but do not evaluate, an integral expression for the volume of the solid. Okay, so this is a little bit trickier. So let me go ahead and bring the picture down a little bit, right? So this is part C. The picture is going to be looking like so. Here is my region R, like so. But now our cross-section is perpendicular to the y-axis, and these are squares, like that, right? So it's a dy function. Because it's perpendicular to the y-axis, is a dy function, okay? And now it's going to go from 0 to 4. So the volume of this is going to go from 0 to 4. That's all I know. I know they're squares, so it's whatever it is squared, because that's the area formula for a square. It's going to be a dy. So now the biggest difference is now instead of top minus bottom, I have to go right minus left. And so this right function here, if I solve it for x, I root both sides. This becomes x equals root y, right? Plus or minus root y, but we just want one side of it. Same thing with this. If I get x by itself, this becomes x equals y over 2. So now, using that idea, my right function is root y minus my left function, y over 2. So my final answer would be the volume is integral from 0 to 4. And this is the right minus left function squared, because this is a square, and then dy. That's it.